So we're in the midst of talking about exponential growth and decay. We're going to take a minute here to go back and chat a little bit about what we were doing with this yesterday to make sure we're on the right page with things. So first things first, let's see if we can remember this. Everything that we did yesterday bases on this little mini formula, this A times BX, which we had in the front of the packet. The B determines whether it's growth or decay, and the A value we found out can move my y-intercept, can make my graph really stretch, some other things like that, or make it open, down, or up. So first question, what's my B value for number 7? 1/3. So if that's my growth or decay factor, is this going to be growth or decay? Decay. Because we talked about yesterday, decay is going to occur when that B is between 0 and 1, basically when it's a fraction. Okay, so I got that part down. Let's see if we can remember some of this other stuff. What would my y-intercept be on this one? Okay, 5 or 0, 5, because my y-intercept, when there's not a shift, goes along directly with what my A value is going to be. Okay, so good. So when I get to here, I may remember some of the other stuff, I may not. So this is where I might want a little bit of help. So if I go to type this in my calculator, okay, get my 5. Remember, just like it is in the problem here too, any fractions we need to be in parentheses. And this is going to the x power. So I want to make sure that I'm using my exponent button and not just writing x. I'd get something completely different otherwise. So if I look at the picture of it, I notice, hey, it's decay. It's coming down as it comes to the right. That's a good thing. And I can use my chart to get a little bit of an idea of some of the values. Well, I notice right away, if I hadn't, there's my y-intercept, 0, 5, just like I thought. That's good. And then I'm just going to plot some of the other values. Now, I know that's tricky on some of them because of the size of our graph. Like negative 115. You're like, oh, that's kind of like way up here somewhere. Oh. And I'm just going to sort of work my way through. But the one thing I'm going to stress is the same thing I stressed yesterday when we were doing these. If I were to keep scrolling down, we're going to get closer and closer to 0, but we're never going to pass it. So when I'm drawing my graph, I can't go past the x-axis. Otherwise, I'm not graphing appropriately. So I can get that drawn in. And then, notice, if you just get your values from the graph here, I really don't care if you don't put them in a chart over here, because a lot of the times when we're doing the work, we're not going to have a chart given to us anyway. So as long as I get those values in, that's fine. So, nice thing, we spoke about this before, my domain, no matter what when I'm doing growth and decay, is negative infinity to infinity, because it goes forever to the left and right, no matter how much I shift it or move it. Now my range, again, I got to think a little bit. Range is my y values from bottom to top. So what would my range be? 0 to infinity. And this is always the case, and we'll make note of this again. Except if we have an up or a down shift. And again, we'll talk about that in a minute, because that's what we're going to kind of roll ourselves into here momentarily. And our end behavior also, then we'll kind of take a peek back here in a second for this as we're doing it. Remember, there's an absolute connection, a correlation between my end behavior and my domain and range. Since my domain's always negative infinity to infinity, I'm always going to have those two values with my x's. Okay, that doesn't change with these. My f of x, my y, directly connects to my range. So my two range values are going to be 0 and infinity. I just got to figure out which one goes where. So as x goes to negative infinity, as x goes left, Am I heading towards 0 or infinity? Infinity. And if I head towards infinity on that one, as I head to the right, I better be heading towards 0 or something's wrong. Oh, I am. Okay. And I just kind of follow that. And that's all I need. So there's not a whole lot of complexity going on with this. It's just kind of working our way through those things. And it'll be the same thing that's working on number 8. We get practice with a couple of the different things. So first I look and I go, okay, what's my B value? My B value is 2. So what's that mean as far as this is growth or decay? Growth, because it's bigger than 1. What's my y-intercept? 4. So 0, 4. Again, it's a coordinate point. Don't just write 4, because 4 is just a random number. That really doesn't tell me a whole lot. So I get that in. And again, if I want, I can take a peek at my calculator to help me out. Again, don't forget my exponent button. I'll look at my graph for a minute just to make sure this looks right. Yep, growth, we're going up to the right. Okay, feeling good there. There's my y-intercept, just like it should be. And I'm actually going to get a few more points in this time, so that's nice. And again, you don't have to use every single point, but just keep reminding yourself, my graph is not going below the axis because there's no up or down shift going on here. So once I've got that drawn in, and I've got all my other information so far, again, my domain and range should be fairly simple to work with, especially the domain. Always forever to the left and right. Okay. Now my range, I know my graph looks different, but my range hasn't changed because it's still bottom, which is down here at y equals 0, to top, which goes up forever.
I have a question.
Sure.
You know how there's like the boxes? X and Y thing? Do you care if we fill that out?
Nope.
Okay.
Don't care a bit. Because what I figure in the question, in case you didn't hear it, was do I mind if you have the box? On a lot of the worksheets, I don't have the box, so if you wanted to draw it, you could, but otherwise I'm just assuming you're taking it off the calculator anyway.
Okay.
So yeah, that's fine. If you just take it off of there, it's all good. So my end behavior, now let's see if this changes at all. Again, the f of x part is the part that changes on me. The x part, the second part, is always just going with my domain, which is negative infinity and positive infinity. And again, my range values, since they're 0 and infinity, I already know what they are. Now it's just making sure they go in the right spot. So again, as x is going left, okay, as x is going towards negative infinity or approaching it, am I going towards infinity or 0 for y? It looks like 0. You're like, oh, so they just kind of flipped around here. But again, that's something, if you just take your time for a second, it's not going to be that big of a deal for you. Okay, so that basically, with those two problems, covers everything we did yesterday. Okay, kind of seeing where everything comes from. So now we're going to add a little something to it. Oh, gracious. Okay, all of these shifts that we do, okay, we've been doing shifts since first quarter. We've shifted parabolas. We've shifted square root functions. We've shifted a whole lot of stuff. Well, now we're just going to do the same thing here. So here's how the application works when we're doing it with these guys. The exponent, okay, if there's a plus or minus shift there, that's going to be my left or right shift. And again, as usual, it's the opposite of what you would think. So if it's minus, I'm going right. If it's plus, I'm going left. Okay, but that's up in the exponent. If it's the one that's on the end, my k value, that's my up and down shift. And again, just like it always has been, that pretty much goes with what you think it would be. Up is going to be plus, and down is going to be minus. So when we get asked to graph something kind of funky like number 9, It is in a lot of ways. The shifts don't change really. The difference is going to be we really don't do as much with a base graph, so we're going to let the calculator do a lot of the work. But my domain and range is going to go a lot with what we've done before. So actually, let's chat about that before we even graph it. Okay, what are my two shifts going to be this time?
Right 1, down 4.
Okay, right 1 and down 4. Because there's my right, okay, my minus, and there's my down. So what does that mean? Well, as far as my domain goes, it doesn't mean a darn thing. Because we've said before, that's never going to change. But if you take note of what we mentioned back in number 7, my range, unless there's an up or down shift, ooh, there is. So if I shift down, I take that number away from my range. So instead of 0 to infinity, my range is -4 to infinity. I can figure that out before I ever look at a picture. Okay, a lot of my information can be done without that. So when, yep. So when we go to type it in, here's what I've got to be careful of. And I'll actually draw it in up here as I do it. So I do 3 times 2. Here's the part people forget and it messes them up. Okay? When I go to do my exponent here, since there's a shift, I've got to make sure that I put parentheses. Because if I forget those, I'm going to have myself a little issue. And if you're using a fancy calculator where it pops up and you don't use this little caret, you're going to need to right arrow when you get to the end, or your -4 is going to be up in your exponent too. So a couple things to consider. So it should look something like this. Let me hit the graph so you can make sure your picture looks right, because that's one thing we all have the same thing on. So that's what my picture would look like. And you'll notice it's not hugging the x-axis anymore. It's shifted down. I wonder how far down it's shifted. When I look at my chart, okay, because you'll notice I can't just use the 3 anymore for my y-intercept either. That's a different issue for a different time. That's why I didn't ask you for it. But when I start looking to see, well, when does this start to level off, we get really close to 4, but notice it's still decimally. We never get there. Okay? So when I go to graph this, let me use my whole numbers still. Let me come back to some normalcy here. When I go to graph this, I'm going to plot my points, at least the ones that I can fit. And notice the value that I'm using for my range, -4, is where my graph kind of curves off and doesn't cross anymore. That's kind of the cool thing about doing your domain and range first. Because now I know, now I know with my range being -4 to infinity, my graph's going to get close to -4, but it's not going past it. And I like sometimes drawing that line in there. Again, it's called an asymptote. But that dotted line, just to remind me, graph can't pass that point, otherwise I'm going to get myself into trouble. But our biggest thing here is just understanding the shifts and what they would do to my domain and what they would do to my range. Okay? It's not going to change my end behavior stuff like it did before. It's just going to change those couple of values. So to make sure we got this, we're going to do a couple things. First, okay, for these last 3, it says state the shift, then state the domain and range. Notice we don't have graphs anywhere. So f of x is my original, and this is my new. So basically all it's asking for is what's changed. What's that -3 going to do shift-wise? Which direction are we heading 3? Down 3, because it's not in the exponent. So if I shift down 3, that still does not change my domain at all. It never has. Bless you. But what's that going to make my range become? -3 to infinity. Because any up or down shift moves my range. Now, does that mean my range is going to change every time? No. Bless you, gracious. So, if we go to 11, I see that minus 1. That's the difference. What shift does that minus 1 represent? Right 1. Because again, up in the exponent is left and right. Again, doesn't change my domain a bit, but does that change my range? Not a bit. So if my range doesn't move, my range is still at 0 to infinity. That's my default. Okay? Unless you see an up or a down shift, that range is going to be 0 to infinity. Every time. Not even an exception, which we normally can find. And then last one. Oh, we got double shifting. All right, what are my 2 shifts? Okay, left 1 from the exponent, down 2 from the end. Still doesn't change my domain. I can shift and stretch and all sorts of things. Doesn't do a thing. What about my range? Right, because the down 2 moves my range with it. If I'd have had an up shift, it moves that too. Okay? So, to reinforce some of this, we've got a worksheet to go with this part. So here's how we're going to do this. Make sure I switch these over so we can be on the same page here. Okay. So the one you got today, exponential growth and decay, notice the directions are different depending on which part you're doing. For 1 through 4, you're going to figure out if it's growth or decay. You're going to sketch the graph. You're going to say the y-intercept. You're going to do the domain and range. We're going to do the end behavior. You're like, dang. So that's basically like the first 2 that we did, number 7 and 8 from the notes. It's the exact same stuff we're doing. But that's not where my focus is going to be because we did that yesterday and we've done it today some. My focus is going to be on the back. We're still going to do growth and decay and the graph, and the domain and range, and the end behavior, and the shifts. Notice no y-intercept when we get back here because that gets kind of funky. So when I get back here, let's just say we jump in on 5. That's the first one. Might as well do that. First things first, what are my 2 shifts on this one?
Left 2, down 1.
Nice, okay. Left 2, down 1. Awesome. So, let's see here. I'm looking to see what my other directions are to make sure I do this all. Okay, so with that information alone, I should be able to figure out what my domain and range are going to be. So what's my domain going to be? Negative infinity to infinity, what it always is. What about my range? Yeah, since I moved down 1, that directly affects this. So negative 1 to infinity. And maybe, just maybe, I decide, you know what? I'm even going to kind of put that little dotted line in here just to remind me, okay, when I graph this, it ain't going below there. Not that it really could because my graph goes all the way down to that point. Sure.
It says that we have to do the growth and decay.
Yes.
So, what the heck would that mean?
Okay, so the same rules still apply when I'm trying to figure out growth or decay here.
Negative 1 or
What's my B value? Okay, reminders.
oh, maybe 1/2.
Yes, because when I'm trying to figure out if it's growth or decay here at the beginning, I'm looking strictly at that value that I'm taking to the exponent. So here, since my B value is 1/2, this is going to be decay. The shifts and things don't make a difference on that. That B value, that value that I'm taking to the exponent, is the entire thing that determines whether it's going to be growth or decay. So I, at this point, with what I have left to do, which is end behavior and graph it, I'd probably graph it. So if I go to graph, let me shift this over. I'm going to go ahead, I'm going to get this typed in. So I'm going to get my 1/2 in parentheses. Reminder, if you have a shift in the exponent, put it in parentheses. Okay, if you don't, you're going to get yourself into trouble. Okay, so that's what this should look like going in. Once I get that in, okay, I can kind of take a peek. I'm going to sneak peek at the graph to see if this looks right. Okay, notice it goes slightly below the x-axis. This looks sensible. Let's see if I can get me some good values to work with here. So -5, I go up to 7. There's some advantages in me putting some of these funky looking graphs on here. We can get more points on. So basically, I'm going to try and graph as many points as I can, just because it helps me to be a little more accurate with what I'm doing. And again, don't go below -1 with your graph. I'm not doing a thing. So once I get those points plotted, I get my graph drawn, the only thing left that I have to deal with is figuring out what my end behavior is going to be. So reminders with the end behavior. Okay, there's always two pieces. Kind of can see all the information that we can get out of these. And then that second part, the x part, always goes with my domain. So that's always going to be the same. It's always going to be one is positive infinity, one is negative. And as I'm doing this, again, now my choices are, when I get to this part, that again goes directly with my range. So I just got to figure out which one's -1 and which one's infinity. So as I'm going left, am I approaching -1 or infinity? Infinity. Which means the other one is my -1 because there's that connection. Okay? And that's all I'm doing on these. So the graphing rules are really going to be the same no matter what, even with the shifts. I'm just letting the calculator get me some extra points that way. Okay. So, questions at this point? So we're going to sort of go from one spot to another here. Okay.
So does growth and decay, does that determine if you use positive or negative?
No, growth and decay just determines that as time continues, whether the amount you started with is getting smaller or as you go further along, the amount you started is getting bigger.
Okay.
Yeah, that's really all it's going to depend on. The values that I use when I'm plotting my graph depend on so many other things. It depends on my base. It depends on my shifts. So there's not really a connection with those. Okay? Okay, now, I'm going to do something dangerous. I'm going to be like kind of reinforced there. Now we're going to switch up for a second. Because remember, when I was talking just before we started this, I'd said we're going to sort of spiral a little bit today. In that we started back with some graphing, kind of built on our graphing from yesterday. Now I actually want to apply this for something. And this is going to spin a little bit into yesterday as well, because the growth and decay factors that we talked about yesterday, we're going to actually use now. And then tomorrow we'll use as a day to kind of bring it all back together, take some time and look at everything a little more in depth. So, switch over with me. I know some of you love getting rolling on something, but if you don't see this at all, it's going to kind of mess you up. So the note sheet you picked up today is going to talk about what's called a growth or decay model. In other words, we're going to actually apply something with this. And like we said yesterday, when we're doing something that grows, hopefully like interest on money that you're making, not paying to somebody, something like that, we use this 1 plus R, 1 plus the rate of growth. If it's decay, maybe like bacteria or something like that over time, that's going to be 1 minus. So that's what I have to figure out first on every one of these as I'm doing them. So I look and I go, okay, so 13. A scientist estimates that a specimen begins with 730 bacteria. Okay. This is my starting value. That A that's in both of these formulas is what am I starting with? Okay, actually let's make a little note of that. So when we're doing these, the A value is what I start with. The Y value is what I end up with. Okay? So whatever calculates over here equals what I'm going to have at that particular point. So I've got my A value. I've got my 730. If the specimen grows by 35% every minute, okay, there's my rate. But remember, I need that as a decimal. It is. So my R is going to be 0.35. So I've got A, I've got R, goes by 35% every minute. Write an equation that represents the bacteria's growth. Now notice it didn't say after 5 minutes, after 10 minutes, after 2 minutes. It just said every minute. It was very general. So this every minute is just going to stay as T. It didn't give me a specific number. So when I write the expression, you're like, now what's this A? Sometimes they use A instead of Y. I really don't understand why, but we're not going to worry about it. So my A value is 730, my little a value. Am I going to be plussing or minusing the 0.35? We're going to be adding because it grows. So 1 plus 0.35, and my exponent is just going to stay as T, because I don't know specifically what time, at least not yet. So then I get to the next part. And it says, how many minutes will pass before the bacteria reaches a population of 9,000? Okay, so here's how we're going to do this. We're going to let the calculator help us out. We're going to go to the y equals, and we're going to type this expression in. So I just type what I see. I don't have an exponent T button, so I'm going to use X instead. And I'm going to go to my chart. So you'll notice when I get to the chart, 0 is my starting point. There's the 730 that I had. So here's what I need to do. What I'm trying to figure out is, what's the X value when Y becomes greater than 9,000? I'm trying to figure out what year am I going to be in when what minute, when Y gets to be bigger than 9,000. So what I typically do is I just start to scroll down. And I notice when I get to minute 8, my Y value is 8,000. I'm getting close. When I get to 9, it's at 10,000. I'm going to use whichever X value is the time that it gets over that. So here, 9 minutes. I know some people that'll say, well, can I write 8 to 9? Because it happens somewhere in between. I wouldn't be bothered by that, but if you're going to write one time, we want to write the one that's after it's occurred. And that's it. That's what I'm trying to do. So I could answer it for when does it happen, after how many minutes, whatever I want to do. So this also would apply not just to bacteria. Oh, no. Okay, you buy a car for $36,000. That's going to be my A. Very nice. My little a, $36,000. The value of the car decreases, so it's going to be minus, by 14% each year. 0.14, which would be my R. Write an exponential decay model for the value of your car. Okay, so 36,000. My car is depreciating or decaying in value. 1 minus 0.14. And again, it just says each year, so we're going to keep it at T for right now. That'd be my model. Because now if somebody walks up, well, how much is the car going to be worth after 2 years, after 10 years? You can tell them. You just plug that value in for T. But notice we actually have a number to plug in this time. So I'm going to go back to my y equals. Get it typed in just like I have it there, making sure I use my exponent button. And it says estimate the value after 3 years. So go to my chart. There's my new car, 36,000. 3 years later. And if you want to get really specific, you notice if I go over there, it just says 22,898, which is fine. But if I hover over it, I get the actual like value, like really detailed. Can't forget the cents, you know. And here even it'd be less than that because the point's not there. It would just be 2 cents actually. But still, hey, you get a lot of 2 cents together, it could add up to something. No, if you just put the 898, I would not mark it wrong. Okay? And then graph them out on your calculator. We kind of already did that. Estimate when the car will have a value of 15,000. In other words, when is Y going to be, you know, less than that? And right, when I hit year 6, now it's below that. So about 6 years, okay?
So we're just estimating.
Yeah, we're just kind of getting close. We're not going to get it down to the day, like 5 years and 38 days. And yeah, we're not going to get into all that. Okay, so that's just a basic growth and decay model. Now we get into moolah. Now see, this is where my interest is. So I get a little more excited about this. Interest?
No, because it doesn't tell you, like, trying to balance up to 1 year if the interest was compounded.
Ooh.
With the given frequency. So, like, I have to do all 3 of them? No.
See? So, compound interest, okay? This is why the people that understand money have it and the people that don't. Because it's trying to figure out what's going to be best for you here. So here's this equation, and again, on any quiz we do with these, the equations will be on it, so it's not like you have to memorize everything. Okay, P is the initial principal, the amount you start with. Okay, it's still my start number. R is still interest, it's still as a decimal, so that hasn't changed. Here's the new one. N is the number of times compounded in 1 year. In other words, if I give you a word like annually, well, annually happens once a year. That's the definition of annual. If it happens quarterly, how many times does something happen in a year if it happens quarterly? 4. So my N value in that case would be 4. If it happens daily, how many times does daily happen in a year? 365. And again, we can use things like weekly or monthly or whatever. So here's what this comes down to. I deposited $1,000 into an account that pays 8% annual interest. I wish I could find that right now. Find the balance after 1 year if the interest was compounded with the given frequency. Okay, so principal 1 plus, 8% is a decimal. Close, that'd be 80%, that'd be even better. 0.08. Okay, over N, and then my exponent is N times, and since it's 1 year, my T is 1. Now, just an FYI, let me get this out of the way. If they're only asking for one specific time, I don't need to use the Y equals. I could, but I don't need to. I'm just going to type this in the regular part of the calculator, but you'd get the same thing if you did it that way. And now basically it just comes down to being careful and making sure you type it in right. Get all my parentheses in where they belong. Let me double check and make sure I did this. Oh, I don't want 2 parentheses. I got a little trigger happy. Right. So I hit that and I find out at the end of that year I'd have $1,080. The question now becomes, because my formula is N times T. My N value was 1 and I was looking for it for 1 year. That's why I did the 1 times 1. So the only thing that's going to change when I do this for quarterly is that my N value now is 4. So both places where there's an N, I replace with 4. So once down here in my denominator, my fraction. For all 3 of these, because we want to see, because here's what banks and places with finance generally do. They're going to try and use big words to make their stuff sound better than everybody else's. Well, we compound our interest quarterly, and they only do it this time, or we do it continuously or daily. And what I want you to see through this is basically that's just a big line of hooey, and it really isn't going to make that much difference at all. Because notice how much larger my account balance here is going to be. Now, I'm not saying it's not better. I mean, if you were talking about, tens of thousands of dollars, we might, be able to go to McDonald's and get a value meal out of the deal. Right now, we can hit the pick 2 menu for going to quarterly. Okay. But it kind of lets you see it comes down more to interest rate than it does how many times you're compounding it. Because, I mean, seriously, if you think about it, you would think this last one, daily, I'm going to take something to the 365th power. You would think this is going to be just an absolutely ginormous amount of money compared to these other ones. But what you are about to find out is that in the big picture of things, we're talking like a little over $3. Now again, if we're into thousands of dollars, maybe this is a little better. But if not, we kind of see how this works. Okay? And I'm not going to drive you crazy by doing every single thing on here because that'll drive you nuts. So let's go to the back. Let's find a couple more things. We're going to be whacking number 21 on the bottom, but I want to hit these special cases because then I'm going to have us ready. Tomorrow's basically going to turn into a work day so we can kind of do some of this. How many years will it take for an account to double its value if it collects 4.5% interest compounded monthly? You're like, okay, I got an issue here. How many years? Okay, there's my T. For an account to double, 4.5% interest, my R is 0.045, okay. Compounded monthly, my N is 12, okay. They didn't tell me how much money I started with. So what's up with that? Well, okay. If you're given no starting amount, and this can happen sometimes, make one up. So you can start with $100, $1,000, $1,000,000. I don't care. Normally I do 1,000 because it's a nice number to work with. If you want to use 2, you use 2. So in this case, my made up original value, my principal, I'm going to use 1,000. So I start to look at this and I'm like, okay, so 1,000, what I start with, 1 plus my rate over 12, because again, monthly means my end value is 12. I don't know how long. That's what I'm trying to figure out. But here's the other piece of information I need that I haven't quite gotten into my equation yet. How many years will it take for my account to double? Okay, if I started with 1,000, how much am I going to have when it doubles? 2,000. So that's going to be what I'm going to have at the end. I have every single value now that I need except the T value. So here's how this works. What I'm going to do is I'm going to type this part, not the 2,000. We'll use that in a second. But we're just going to take this part on the right and we're going to put it into the y equals. And again, we're just going to use x in our exponent because I don't have t to work with. But everything else I just type in that same way. And similarly to what we did when we were looking at like for the when's the car going to be worth this or that, this is the amount. When does y equal or y is y greater than this? So I look at my chart. And I start scrolling down, started with my 1,000. And when that y column goes over 2,000, it's going to take 16 years for that account to double. Okay. So there are some twists to what I can use this formula for. So I just got to read in, see what information I have, and kind of build it. So the last thing that can happen, okay, the banks tried to smooth you over with monthly and daily and all this other stuff. This is the biggest one, though. You ready? What if I'm willing to compound your interest continuously, non-stop cash going into your pocket? Okay. This is such a huge thing, we had to come up with its own formula for it.
What is PE?
PE. E is actually a number. And so it's on the calculator. So to get E on my calculator, and we'll get to that in a second, we'll just do this first one for an example here. So my P is still my principal. E is a value, so that just stays E. And then R times T. So you're like, okay, how do I do this? Oops. Clear that out. How do I do this E thing? So 1,000. To get E, you hit second and natural log, ln. It's down the side here. If you hit second and ln along the edge, you get E, and it automatically turns it into an exponent for you. That's kind of nice. And even gives you the first parenthesis. So I just got to type in the rate and the time, and I get the answer. That's kind of slick. That's it. So all I'm really doing through all of this, and I'm going to use number 20 as my last one because it's weird and we like to deal with weird stuff. How long will it take for the account balance to triple if it collects 5% continuously? Okay, again, I'm going to keep using my 1,000. You use whatever you want. So 1,000 E, my rate is 5%, 0.05, and I'll just use X here instead of T because that's what we're going to put on the calculator. If I start with 1,000, I want to know when it triples. That'd be 3,000. Okay. So I type what's in blue in the right side into my calculator and see when it gets to 3,000. So 1,000 second ln 0.05x. And again, I start scrolling down until that Y column hits 3,000. We whack that out. So I blasted number 21 because we don't need it for any of the problems that we're doing. And so the part on this that, again, we'll have some time to kind of go back over this and work on it tomorrow, is on the front. There's a book part to this. And since there's no graphs to deal with, I didn't give out a worksheet for that part. Okay?
So is this homework?
Yes. That worksheet and dealing with this bookwork at the top is the assignment, but you will have in-class time tomorrow to work on this and some more application things that we're going to be doing.